What in God's green... Wait, I have the wrong outfit. That's better. What in God's green earth is chemical kinetics? Why does science have to interfere with almost everything unusual? Well, my friend, it's simple. Motion, according to Google, is the change of position over time. And kinetics, on the other hand, has a pretty complicated relationship with motion. It just so happens that our planet revolves around movement and its equal reaction to it. If I move to one place, I go a step further. That's how simple motion is. According to the late great Albert Einstein that developed the theory of relativity, he designed the formula E is equal to mc squared, which simply translates to energy is equal to mass times the speed of light squared. What does it have to do with chemical kinetics? Energy, perhaps? You see, in every equal release of energy, there is an equal reaction to it, thus the answer to the question, what is chemical kinetics? Furthermore, it can determine how fast or slow chemical reactions happen. As I said, we revolve around movement, and everyday tasks just so happen to have what they call chemical kinetics. Don't worry, you will not be left out with much information. They're still coming in the way. For now, enjoy. Hey guys, it's me, and this is a vlog. It's nice to know that there is a branch of science that supports our everyday reaction to everything that is created by mankind. So let's see what my friend has to say with what chemical kinetics is. Take the mic, buddy.
Chemical kinetics is a branch of physical chemistry that focuses on the different rates of chemical reaction. It is said to be connected with thermodynamics, as thermodynamics focuses on the direction in which a process occurs but does not tell anything about its rate. Chemical kinetics includes chemical reaction, reaction to mechanism, and transition states. According to Laidler-Keith, chemical kinetics relates to many aspects of cosmology, geology, biology, engineering, and even psychology. And with that said, its implications could further reach more.
If you know what chemical kinetic is, I'm sure that you'll also be interested on whose name ran a big figure in chemical kinetic field. In 1864, Peter Weig and Cato Goldberg are the chemists that are said to be the pioneers of chemical kinetics. Augustus George Vernon Harcourt is one of the scientists that had a very significant contribution. Now that you have some background knowledge into the topic, let me discuss you on how chemical kinetics used in real life. As it is said, everywhere you look, chemicals are evident. Chemical kinetics are happening everywhere. One of the examples is temperature and its rate.
Well, for me, that was a very good explanation. So let's see what does he have to say about cooking and chemical kinetics. Take it away.
One of the examples of chemical kinetics is cooking. In mixing dry ingredients, usually doesn't result in a chemical reaction, but adding a liquid ingredients often result in a reaction. Cooking with heat also causes reaction. Mixing flour, sugar, and salt is not a chemical reaction. Neither is mixing oil and vinegar. Cooking an egg is a chemical reaction because heat polymerizes proteins in egg white, while the hydrogen and sulfur of the yolk can react to the caramelization occurs. When you heat meat, it browns due to the Maillard reaction. Baked goods rise due to the carbon dioxide bubbles formed by the reaction between baking powder or soda and a liquid ingredients.
One of the examples of this is digestion. Digestion is a complex process that involves thousands of chemical reactions. When you put food in your mouth, water and the enzyme amylase break down sugar and other carbohydrates into similar molecules.
So I was just informed that drinking medicine also has the application of, you guessed it, chemical kinetics. Well, let's see. If you drank the proper dosage of medicine, of course you'll get better. That's That's the equal reaction to it. Well, if you drank copious amounts of medicine, then you are overdosed. The rate of it will vary on how much you took, but that is the point of overdosage. Even the simple task of washing dishes. Imagine, washing dishes has science? Well, here's the proper guide to explain everything.
While I was cleaning the dishes, something suddenly came out of my mind. That why is it if a soap detergent is mixed with water, it produces foams and bubbles? Well, according to my research, in simpler terms, when soap detergent molecules is mixed with water molecules, they tend to separate out of small bits to form bubbles. When soap mixes with water, the opposite ends of soap molecules sandwich a thin layer of water between themselves. This creates a thin film that encompasses a tiny bit of air. In short, soap detergent is added to water. It lowers the surface tension so that bubbles can form. And then because of that research, I suddenly realized that wow.
So imagine baking and science. Wow, that just so happens to be connected. So there's this girl that can explain it for you.
Chemical kinetics application in baking. These are the some reactions you have to keep in your mind. Is baking a cake a chemical change? Next time you bake a cake, think about it. When a cake dough is heated in the oven, a chemical reaction occurs and new bonds are formed. There are two types of chemical reactions to consider. The one is the endothermic. It is a reaction that takes heat in, while the other one is exothermic, a reaction that produces heat.
So that is it for the vlog. Hope you all learned something about chemical kinetics. Thank you. See you on the next vlog. Informational video. Peace.